one more. Cool. All right. So last time we took our first exam, and I've got everybody's exams compiled and everything like that. I didn't have a grading sheet at home. I thought I could download it from the Hawks website, but it wasn't letting me do that. So I'll have the grades, all the grades done tomorrow. But from what I've seen, they look decent. I think we did pretty well studying with the review. Okay, so let's go over this today. So number one says determine whether the statement describes a population or a sample. Okay, so it says the amount of money each person in your chemistry class spends eating out in a week. Okay, so is this a population or a sample? Population, yeah. So again, it says the amount of money each person in your chemistry class spends eating out each week. Well, it's not defining this as a sample because that'd have to be a part of the chemistry class. This just says the chemistry class. So that would be the entire thing. That'd be a population. Good. All right. Number two. If the researchers administering care know which partakers have been placed in the experimental or control group, but the partaker does not have this information, the experiment is what? Single blind or double blind? Single blind, yes. So in a single blind study, the researchers know who's in what category. Just the people in the study don't know what category they're in. In a double-blind study, the participants don't know what category they're in, and the researchers don't know either. Okay, good. Number three. Determine whether an observational or experimental study is appropriate to address the following statement. A car wash operator wants to find out if a need for additional staffing exists. Okay, so would this be observational or experimental? What do you think? I'd say experimental, though it could be done observationally. So I'd say experimental because you could hire somebody and put them in there and see if they need to, if they need to keep hiring more people. How does that person affect their performance? Observational, you could get away with theoretically by just seeing, okay, how much volume are we able to take in? But I think an experimental study would be better for this one. Any questions? Okay. And number four, a college administrator wants to know if the SAT scores of incoming freshmen have an effect on their end-of-year freshman GPA. Okay, so the SAT scores would be considered the what? So we have a response variable or explanatory variable. No, a response variable would be a direct response to their SAT scores. So the response variable here would be their end-of-year freshman GPA. Okay, so this would be the explanatory variable. Again, what he's asking is, do the SAT scores have an effect on their freshman GPA? Okay, so the affecting thing is the explanatory variable. Any questions? All right, let's move on. Next, a mid-sized mobile carrier keeps records of complaints received from its customers. Complaints for last month are listed in the following table. What percentage of complaints are due to the category extra data usage charges? Round your answer to 2 decimal places if necessary. Okay, so first of all, where is that category? Extra data usage charges, it's right there. So we want to know what percent this represents out of the entire table. Well, then the first thing we need to know is what? Yeah, total, the sum. Okay, so let's go ahead and add all these up. So 118 plus 99 plus 87 plus 92 plus 106 plus 89 plus 43 plus 156. So we get 790. Now, is 87, is that the part or the whole? Yeah, it's a part. So you could multiply that one by 100 and then divide by 790. That's one way to do it. You could also do 87 divided by 790 and then multiply by 100. Oh, I mean, they're both perfectly the same thing. No, you're right, yeah. But the thing is, make sure that you set this up as this is 87 out of 790, because I did see a few people set this up as 790 out of 87. Remember, this has to be the part out of the whole. So the part has to be on top. My phone needs to be turned off. Sorry about that, guys. But yeah, the 87 needs to be on top because that is the part. Okay, but yeah, either way that you described would work. So we could set this up as a percent out of 100 and then multiply 87 times 100 and then divide by 790. Let's go ahead and do that. So 87 times 100 and then divide by 790 is 11.01, and it said round to 2 decimal places, so let's see, it's 11.012, so that won't round up. So there's our answer. Any questions? All right. So next one says determine the mean of the given data, determine the median, and the mode if there is any. Okay, so we've got negative 13, negative 5. Okay, we need to set this up in order. So let's see, negative 14 looks like our smallest. And then negative 13, negative 8, negative 7, negative 5, and just regular old 5. All right. So again, the first thing we need to find is the mean. So let's add all these up. So negative 14 plus negative 13 plus negative 8 plus negative 7 plus negative 5 plus 5 is going to give us negative 42. And then what do we need to do with that number? Data points, yeah. So let's see, we have 1, 2, 3, 4, 5, 6 data points. So we'll divide negative 42 by 6, and we get negative 7. There's our mean. Excellent. Okay, how about our median? Okay, well, we need to find the middle number, so we count in here, and we have two numbers in the middle, -8 and -7. So what's directly between -8 and -7? Yeah, -7.5. Good. And then what is our mode, if we have one? Yeah, there's no mode here. In order for us to have a mode, we have to have a number that repeats. Well, none of these numbers repeat. So there is no mode. Excellent, excellent. Okay, next. Calculate the GPA of a student with the following grades. C is 16 hours, B is 5 hours, and D for a 12 hours course. Okay, note that A is equivalent to 4.0, B is 3.0, so on and so forth. Okay, so we need to calculate a weighted mean here. So the first thing we need to do is convert these letter grades into actual values. So again, we have C, B, and D. So a C is worth, let's see, 2.0. And B is worth 3. And D is worth 1. Then we need to do what with these numbers? Yes, so we need to multiply our weights by our values. So let's see, 16 times 2 3 times 5 and 1 times 12, and we will add all these up. So let's see, 2 times 16 is going to be what? 32. 3 times 5, 15. And 1 times 12? Yeah, 12. Okay. So we're going to add all these up. 32 plus 15, oops, 15 plus 12 is 59. We need to divide this by something. What do we need to divide it by? Exactly, yes. So we have 16, 5, and 12. So 16 plus 5 plus 12 is 33. So 59 divided by 33 is 1.79 if we round it. And there's our answer. Any questions? All right. Next, for the graph shown, determine which letter represents the mean, the median, and the mode. Letters may be used more than once. Okay, so first of all, which one's the mode? Yes. So the mode, of course, is the number that occurs the most. This is a representation of frequency. So as this curve increases, the frequency of that number is increasing as well. Well, if this is the highest frequency, that means that this is the number that repeats the most. So that's our mode. Okay? Then if this is the mode, which one would have to be our median? Remember, median is the middle number. C. Essentially, if we were to look at these frequencies, this would be breaking the numbers in half. So half of our numbers would be represented on this side of our median, and half of our numbers would be represented on this side of the median. It's a little bit skewed. It's not directly in the center because a lot of numbers occur over here and just a few numbers occur over here. So it pushes that median over to the side. All right, and the mean, only one left over. Yeah, always occurs on the other side of the median from the mode. Good. Any questions? All right. Number 9. Consider the following data. Okay, and it wants us to calculate the value of the sample standard deviation and the value of the range. Okay, so first things first, we need our formula for standard deviation, specifically for a sample. Okay, so sample standard deviation is S equals the square root of the sum of x minus x bar squared over n minus 1. Okay. So we need to know a few things here. First of all, what is x bar? What does x bar represent? Anybody? Okay, x bar is the mean. It is the average. Specifically, it will represent a sample mean. Now, that doesn't mean that it's calculated any different from a population mean. It's just showing that, hey, we need to recognize that this is the mean for a sample, just so we keep things straight. Okay, n. What does n represent? Number of data points, yeah. So we can get that pretty easily. 1, 2, 3, 4, 5, 6 data points. That's our n. And let's go ahead and get our mean as well. So we need to add all these together and then divide by the n, which is 6. So negative 5 plus negative 15 plus 3 plus 3 plus negative 5 plus negative 5 is negative 24. Divide that again by 6, and we get negative 4. Again, that is our sample mean. So now we got to put this into our formula and see what we get. So the first part of that is to take x minus x bar, so each of these x values, subtract this one. Okay, so like negative 5, that's negative 5 minus negative 4. Again, we're subtracting the x bar, which is negative. So this is really coming out to be something like negative 5 plus 4. So what does that come out to be? Negative 5 plus 4. Switch them around. 4 minus 5. Negative 1. Remember, if the signs are different when we're combining these things, they're going to subtract from each other. If they're the same, they're going to combine with each other to make a bigger number. So if the signs are different, that means they're going to subtract from each other. So negative 1. Okay. Negative 15 plus 4 is going to give us negative 11. 3 plus 4 is going to give us positive 7. Again, 3 plus 4 is positive 7. Negative 5 is negative 1. Negative 5, again, will give us negative 1. So we've subtracted our mean from each of our x values. Now we need to square them. So negative 1 squared is 1. Negative 11 squared is 121. 7 squared is 49. 1 and 1. Okay. So we've subtracted our x minus x bar, squared them. Now we need to combine them all together. So get our sum. So we've got 1 plus 121 plus 49 plus 49 plus 1 plus 1. So our sum comes out to be 222. And we divide that by n minus 1. So our n is 6, n minus 1 is 5. So divide by 5. We get 44.4. And that would be our variance, but we didn't need variance for this one. Okay, so to get our standard deviation, we take the square root. So square root of 44.4. Where's my answer button? Yeah. Ugh. Well, that's dark. Look, it's 6.66, but it says 1 decimal place, so we've escaped that irony there. Okay. And then finally calculate the range. So what's my smallest number in this original data set? Negative 15, yeah. And then my largest number is 3. So the distance between negative 15 and 3 is what? Remember, think about a number line. What is the distance between these two numbers? 18, yeah, good. Excellent. Any questions? No? All right. Last one, number 10. Suppose that a company wishes to predict sales volume based on the amount of advertising expenditures. The sales manager thinks that sales volume and advertising expenditures are modeled according to the following linear equation. Both sales volume and advertising expenditures are in thousands of dollars. So it's got this little linear equation here. It says estimated sales volume equals 49.48 plus 0.51 times the advertising expenditures. So in other words, if we spend a certain amount on advertising expenditures, we will get a certain amount of sales volume, at least in a prediction. So this goes on to say if the company has a target sales volume of $225,000, how much should the sales manager allocate for advertising in the budget? Round your answer to the nearest dollar. All right. Now, again, like I was saying on the review, this thing is in thousands of dollars. So when we plug this in, we can't plug in $225,000. We have to plug in 225 because that's how many thousands of dollars we have. Okay, so that's the sales volume that we want to get. So we plug it in for estimated sales volume, and then write out the rest of our linear equation here. And I'm using A to represent advertising expenditures. All right. So from this point, it is just a matter of solving. We've got to get A by itself. Okay. So if we want to do that, we got to eliminate numbers on this side. So what can we eliminate first? What should we eliminate first? Yep. Subtract that bad boy from both sides. Okay, so that'll cancel on that side. And let's see, 225 minus 49.48. Oops, 48. That gives us 175.52. Okay, so drop down the rest of our values, 0.51. A. And now what do we do? Yep. Divide both sides by this 0.51. Okay, so again, that'll cancel on that side. Let's see what we get on the other side. So divide 175.52 by 0.51. We should get a pretty decently large number here. Yep. So we get 344. Oh, well, I guess we need to add some more decimal places here. 344.157. Now, this is not the answer I want to put in to my answer box, because what do I need to do with this first? Do what? I've actually already done that. Change it to thousands, yeah. So, move this decimal place 3 times to the right, and we have our answer in thousands of dollars. So there we go. If they want to make around $225,000 in sales volume, then they need to spend $344,157 in advertising. All right, any questions? None? Okay. So, again, from what I've seen so far of our exams, and I've seen most of them already, look pretty good. How y'all feel you did? Yeah? Good, good. All right. So, I'm going to let Miss Lamar lecture tomorrow, and then I'll lecture on what she was talking about tomorrow on Wednesday, all right? So that'll be it for today. I hope you have a good one.